Okay, calculus, here we go. DNS exam number 3, problem number 10. In this problem here, they gave you a function, f of x is equal to e to the 2x, and the question is, at how many points in the closed interval here from 0 to 5, gotcha, does the instantaneous rate of change of f equal the average rate of change of f? Sure sounds to me there like they're talking about a little thing we should know pretty well called the mean value theorem. The mean value theorem, if you recall, guys, tells us that the instantaneous rate of change of a function, given by its derivative, f prime of c, is going to be equal to its average rate of change, which would be f of b minus f of a all over b minus a, and that if your function is differentiable on a closed interval here, that this has to occur a minimum of one time somewhere in this interval right here from 0 to 5. Well, as we think about the function that we're dealing with right here, f of x being an exponential growth function, we know that e to the 2x is continuous, it's defined, and it's certainly going to be differentiable for all values of x because this graph doesn't really do anything weird, guys. It's an exponential growth function, a little bit faster than a normal one, maybe looks something like that, so no reason to think that this thing isn't going to happen at least once, so I can already kind of rule out A, which was none, as one of the answers right here, but it does look like it could be 1 or 2 or 3. Now, if I remember this problem right, I actually think we know the answer already, but let me go ahead and tackle this one the way that I would think you guys probably would. Okay, so what we're doing on the left-hand side is measuring the derivative of this function evaluated at some x value c. So we got to think about the derivative of f of x right here, which I think we can do on the fly. The derivative of e to any power is going to be the same base, e, to the same power, 2x, multiplied by the derivative of that exponent. Well, the derivative of 2x is going to put a 2 out in front, and the exponent would stay at 2x, except we're supposed to evaluate this now when x is equal to c. So we're going to get 2e to the 2c is equal to, and now let's play around with the right-hand side, knowing that our a value is going to be 0 and our b value is going to be 5. So we're going to start off right here evaluating f of 5, which is going to be an e to the 10th minus, and now an f of a, or f of 0, is going to be e to the 0 power all over b minus a, which is going to be a 5 minus 0. Now, yeah, I do remember this one from last year, and some weird things kind of happen here. The denominator of this fraction just becomes a 5, which I think the last time I did this, I decided then to multiply over here to this side to give me a 10. E to the 2c power was equal to, and the only thing that's noteworthy I think in this numerator is that any number other than 0 to the 0 power is 1, so this right side is just going to become e to the 10th minus 1. And I remember feeling what I wouldn't be surprised if some of you guys were feeling right now, which is, wow, if I had my calculator, I could just type in solve and find out how many values of c this would work for. But this is not a calculator question. So trying to solve this one is difficult, but then I kind of remembered the fact that, oh yeah, hang on just a second here, we're not actually supposed to solve for the value of c. We're just trying to figure out how many times this is actually going to work out. So to do that, I want to go back and talk about this graph right over here, and let me do that on a new page. So not trying to get real specific with this one right here, we know that we're dealing with an exponential growth function that's going to do something like this, and it's going to increase at an increasing rate. And we know that the 2 points of sequency we are interested in is one of them right here at 0, and the other one, I don't really care where, but somewhere off to the right at 5. So if we were to draw a secant line passing through those right there. All right, that's our secant right there. And the question wasn't asking us for what value of c will the slope of the tangent equal the slope of the secant, or the instantaneous rate of change equal the average rate of change, but really what they wanted instead was to know for how many values of c that would happen. Well, if we think about what we know with the mean value theorem, I think we can conclude that there's one, and I'm just guessing here, guys, and I'm not going to worry too much about if I'm right or not, but let's say a 1 one spot right over here where we would have a green tangent now that was parallel to that red secant. The question becomes, is there another one? And the answer to that one is no, simply because this function in purple, the original graph we were dealing with of y equals e to the 2x power, is a monotonous function. In order for this thing to have another spot where its tangent was parallel to its secant line, the behavior of that function would have to change. Let me try to show you what that might look like. So we actually saw something like this way back when we were talking about it, that if I drew a function that did something like this, and said, okay, let me use the same colors I used on the last slide here. If I went to red and said I want one of my points of sequency to be right here and another one to be right here, okay, there's our secant line. And now if we were going to try to find tangent lines parallel to that secant, the mean value theorem tells us there's got to be a minimum of one, and I think I have found one right about here, but it kind of looks like there would be another one right over here, and I think we ended up with two. But the reason for that, everybody, is because of our original function, which I've drawn there in purple, is not monotonous. It has changes in behavior. It increases, then it decreases, and then it starts increasing again, all within this interval here from a to b. But because the function we're dealing with right here, the y equals e to the 2x power, doesn't have any changes in between right there, 0 and 5, because its behavior is always going to be increasing, there's only going to be one value here at which the slope of the tangent is going to equal the slope of the secant. So for that reason right there, there's only going to be one solution right here to this one. So we don't know what it is, but we know that this has to happen just one time. So the answer to this is 1, which looks like B is going to be our answer here for DNS Exam 3, problem number 10.